that disappeared when we took the derivative reappears when we take the antiderivative. But we don't know what that constant is, so we just say let's plus some general constant. And we leave it at that. So let's see what we can do here. That's right, I gave them all away, didn't I? So here we've got an indefinite integral.
Oh, that's a 9.
That was a Q.
Yeah, I thought it was a Q or a G or something.
And I just realized what I did, but that's okay.
Okay. The T.
That T, yes, it's 9e to the T with respect to x. I did that unintentionally, but we can talk about it anyway while we're here. So that means that the T has to be treated like a constant, because this is with respect to x. So this is really just a constant. That's all that is. 9e to the T is just a constant, because we're with respect to x. And so the integral of that would be 9e T times x.
That's true. Plus plus C.
Thank you.
Minus 2. There you go.
Fine.
No, I'm saying minus 2 points.
Matters.
I was saying minus 2 points.
Oh, minus 2 points for me? 2?
That's a mean took off.
I'll remember that on the exam.
Just for him.
Yeah.
It's just for him.
No. There's already one Nick Gardner. That's fine. You don't need another one. I'm sorry. You can have your points back.
I think there's a lot of difference between me and Nick. I'm just saying, a lot.
He's mean. He's mean.
I like him.
I like him, but he's
I've
mean on
never
his
taken
problem.
a class from him though, so who knows?
That's right.
Okay, let's do this one now. So that we actually have t that's a variable and we can treat it like a variable and know what to do with it. So the first thing we'll do is we'll pull that 9 out as a multiplier. And then we'll take the indefinite integral of e to the t, which is
E to the T.
that's not too horrible.
You get your points back.
Say what?
You get your points back.
Oh, thank you. You don't.
Oh.
I like to pick on people.
Went from easy to like, what?
This really isn't that horrible.
Negative 3.
First, let's put it into two pieces. And I'm going to take the multiplier out as I'm putting it into two pieces. So it'll be 3 times the integral of cosine x dx minus 2 times the integral of sine x dx. Is it really that horrible?
3 sine x minus 2 plus 2 cosine x. 3 sine x plus 2 cosine x.
Why plus?
Negative and negative cancel out.
Oh.
Plus c.
Okay, let's talk that through. So the derivative of cosine is sine. So we've got 3 times the derivative. The integral of cosine is sine. So we've got 3 times sine minus, and let's just kind of do that so that we can see that, 2 times the integral of sine is negative cosine. And so that's, yeah, talk through it a little bit better. Hopefully it gets a little more clear. Now, this one is kind of nasty, but that's okay, because you have a little piece of paper to look at.
Will we have it for the text?
Inverse sign.
What did I say? Everything but the last three?
Those are the inverse, right?
So we need to know everything.
Yeah, you need to know everything but the last three, because the last three are really complicated, and I'm not gonna smash them into your brain. But remember that you already know these things, you know the derivative of stuff. And so once you've got the power rule under control, the trig stuff is really very simple, except the last three. So the first thing I'm gonna do here is I'm gonna take that multiplier out. And then I'm gonna say, is there some kind of pattern there in my little sheet or in the back of my book, or where is it? Is it in the back or the front?
Yeah. Back up.
Back. Is there something I've got there that fits this pattern? And that's really what a lot of integral calculus is all about, is there something in my knowledge base that fits a pattern? Or is there a pattern in my knowledge base that I can use on this integral? That's, as you get to more and more complicated integrals, that's what it's all about. So there is one that fits that pattern, sort of. Now it fits the pattern, right? Okay. So what pattern is that?
Sign in.
It's what?
Arc sign.
Inverse sign? Okay, can we just throw this in right away? But this has a derivative, right?
So you have to get it.
So if that has a derivative, or if it has, yeah, you're going to have to inverse chain rule. That's what I'm trying to say. So how do we inverse chain rule? I don't know, how do we inverse chain rule? Well, how about if we just do this? Let's call that guy U. And then if we take the derivative of that, hopefully when I do that,
Oh, you get a 1/2. You get an extra one. Because you moved the 2.
there we go. I can't even take the derivative correctly. Oh, why am I doing this? I'm trying to simplify that mess a little bit so that it fits into the pattern better. So what I'm going to do here now is I'm going to change this to a U
So,
integral. 1 over the square root of 1 minus U squared. Just plug that in right there. But I got a little issue here. When I try to plug something in for my dx, all I've really got is 2 times dx. But I can fix that. I'll just divide both sides by 2, and then I have du over 2 equals dx. So now for dx, I'll just plug that in right there. U substitution. One of the best strategies for trying to do integrals. We've seen U substitution before, or when we did the chain rule, right? This is just undoing the chain rule, so, oh yeah, that does make sense. Oh, I didn't even put it there, did I? Let's put it there. So now I've got that crazy little half multiplier there, I'm gonna pull it out. That 2 that's under the du. And I have 1 over 1 minus u squared du. And now it fits the pattern exactly, right? And so I've got 4 times,
Sine inverse. Of u.
say what?
Sine inverse of u. Plus c.
Does that translate directly?
You gotta plug,
Let's see.
well, you need a.
No, I'm, just for here. Does that translate directly from the equation to what's on your paper? Look on your paper and see, is this a direct translation from here to here?
Yeah.
I'm making you think,
But it is.
or I'm trying to make you think.
You need a.
Is it not working?
Do you want your u to be in terms of x? Right now?
Well, we're not that far yet. We're just doing, from this pattern to here, is it good now?
Yes.
Yes.
Okay. And now we need to fix you. Remember this step. I wanted to be sure that you actually got to that step correctly, which you were struggling with me to get. But never forget to plug stuff back in, because that can be really confusing. Especially when you're grading.
So we can use it on the test. We can use u sub on the test.
Yes, you will probably need to use U substitution on the test. But hopefully it'll be a simple one. I don't know, I'm doing great on making up really hard problems for the exams.
No, I asked because she didn't let us last quarter.
Cause what?
She didn't, my teacher didn't let us last quarter.
Oh, she didn't let you use
She
U
took
sub?
off points because they used u sub.
Well, how else would you do this?
It was in secant inverse, and they used u sub instead of the long way,
Huh,
and she took off points.
ridiculous, ridiculous, ridiculous. I feel like we need to do another example. I don't have one written down, but I feel like we need to do one. Ah! That's probably part of, yeah, that's part of your assignment. That's okay, we'll do it anyway. Wow. Well, we could take a multiplier of 6 out, but that's about all we could do. So this one is definitely going to be another U substitution. That's why I said this one will be good, because I looked at it real quickly and saw that it was a U sub. So what we're trying to do is we're trying to get something we can work with. The inverse chain rule is so hard to think backwards through. Much harder than when we actually just do the chain rule. So typically what we're going to do is we're going to look for something that if we take the derivative of it, it will give us the other pieces of the variable pieces. For instance, if I take the derivative of this, I'll get 6x dx. 6x dx. Perfect. So I'm going to say let u equal 3x squared plus 1, and then du will be 6x dx. And then it's just a direct substitution. We'll put u in there, and we'll put du in here. And then it'll be nice, it'll be perfect, hopefully. So we've got the integral of du over u. Good job. Did I plug it in correctly? That's the hardest part. Did I plug it in correctly? And did I get all of my x's taken care of? If I have an x left over, this won't work, because I'm doing a complete substitution of variables, and so you have to do a complete substitution of variables. I probably would do this myself.